Assalamualaikum and hi everyone. We are from Group 7 and we are assigned to solve and explain the answers in PYQ Final Sem 1 2014-15.
Hi, today I will explain question 1. Okay, so A, they give us a velocity and we need to find the acceleration and displacement at t is equal to 0. To find the acceleration, we need to differentiate Vt and then we substitute t with equal to 0 and we get this answer. Then to find the displacement, we need to integrate the Vt and find the C. To find the C, we need to substitute R is equal to 0 here into this. Then we get C and get the answer here. Make sure you find the C. Alright, for B, they give us F, which is a vector, and phi, which is a scalar. So, first question, they ask us to find grad dot grad phi. So first we find the grad phi, and then we find the dot product of grad, then substitute the point here. So we get this answer. So for the second one, we need to find the grad dot grad cross F. First, find the grad cross F, and then find the grad dot grad cross F, and substitute the answer with point P11, and the answer is 0. Alright, for number 3, the question asks us to find the grad dot phi multiply with F. So we need to multiply the scalar and vector first, and then we need to multiply one by one. So this is the answer, and then we need to find the grad of this. So we get this, and then we substitute 0.111, and then we get the answer is 19.
Okay, we go through to the question 2a. If r equal to xi plus yj plus zk and r equal to square root x square plus y square plus z square, show that delta square r to the power of n equal to n in bracket n plus 1 r to the power of n minus 2. So first we find delta r to the power of n. So we use dot product, and then for partial over partial x, we get n x r to the power of n minus 2. Partial over partial y, we get ny r to the power of n minus 2. Partial over partial z, we get nz r to the power of n minus 2. So we find delta square r to the power of n. We use dot product again, and then we differentiate again. We get for partial square over partial x square, we get n r to the power of n minus 4 in bracket r square plus n minus 2 x square. So for partial square over partial y square, we get n r to the power of n minus 4 r square plus n minus 2 y square. So for partial square over partial z square, we get n r to the power of n minus 4 in bracket r square plus n minus 2 z square. So we total up, we get like this, and then when we simplify, we get n in bracket n plus 1 r to the power of n minus 2. Okay, we go to the 2a Roman 2. So show that gradient divergence in bracket r over r equal to negative 2r over r cube. So for divergence r over r, we use dot product, and then for partial over partial x, we get r square minus x square over r cube. So for partial over partial y, we get r square minus x square over r cube. For partial z, we get r square minus z square over r cube. So we find gradient divergence r over r. So we use dot product again, and then we differentiate again, and then we get for partial over partial x, we get negative 2x over r cube. For partial over partial y, we get negative 2y over r cube. Partial over partial z, we get negative 2z over r cube. So when we total up, we get negative 2 in bracket x plus y plus z over r cube. So when we simplify, we get negative 2r over r cube. Okay, next we go to 2b. Find the equation of tangent plane to the surface x z square plus h square y equal to 1 minus z at the point p 1 1 minus 1. So we arrange like this. So x z square plus x square y plus z minus 1 equal to 0. So partial f over partial x, we get z square plus 2xy. For partial f over partial y, we get x square. For partial f over partial z, we get 1 plus 2xz. So when we put the point into the partial f over partial x, we get 3. For partial f over partial y, we get 1. And partial f over partial z, we get negative 1. So equation of tangent plane, 3 in bracket x minus 1 plus 1 in bracket 1 y minus 1 minus z minus in bracket z plus 1 equal to 0. So we simplify, we get 3x plus y minus z equal to 5. Okay, next is 2c. Given phi x y z equal to x cube y minus y ln z plus z cube, determine the direction of the maximum change for the phi x y z direction. So hence deduce the maximum value for the phi x y z, and then hence deduce the maximum value of d phi over ds at the point 1 1 1 1. So delta phi equal to phi x, phi y, phi z. So we get for phi x we get 3x square y. For phi y we get x cube minus ln z. Phi z we get negative y over z plus 3z square. So when we write in the direction equation, so we get 3x squared y I plus x cube minus ln z j plus in bracket minus negative y over z plus 3z squared k. So for the maximum value, we get like this: 3x squared y I plus x cube minus ln z j plus negative y over z plus 3z squared k. So when we put into the point, so we get like this: 3i plus j plus 2k. So the magnitude is we get square root 14.
Question 3. Evaluate
f.dr where f equal to 5yi plus 2xj and c is the boundary of the ellipse x plus 2 squared over 4 plus y minus 3 squared over 9 equal to 1 in anti-clockwise direction. From the ellipse equation, this is the position of the ellipse. Here, we let the f into the f.dr, x equal to a cos t, 2 cos t, we differentiate it, we get negative 2 sin t. For y equal to b sin t equal to 3 sin t, we differentiate it, we get 3 cos t. A and b we get from the ellipse equation. Then, we substitute the value of x and dx into the equation that we get up here. Then we simplify it, then we calculate it, we get the answer negative 18 pi. For b, if f equal to exponent to the power of y plus 2z multiply with I plus xj plus 2xk, show that f is a conservation field. Thus, find the potential function of f, hence find the work done to move an object from 1, 0, negative 1 to 0, 0, 0 to 0, 1, 1. First, we calculate the curl of f. This is the formula. Then we get the curl is 0. So that shown that f is conservative field. Then we integrate the equation for dx, dy and dz. Then we get all the answer are the same. X exponent to the power of y plus 2z and plus c. Work done. This is the formula for work done. We substitute the value up here. Then we get this. So we add all of it, then we get negative 0.1353. For C, use Green theorem to evaluate integration of exponent to the power of 3x power of 7 plus sine x minus 5y dx plus ln y to the power of 3 tangent y plus 5x dy, where C is the boundary of the region bounded by x squared minus 6x plus y squared plus 5 equal to 0. From this equation, we got this. Then, we get this. We simplify it for the ellipse equation. So, we get the center and radius. Then, we substitute into the formula. Then, we get 40 pi.
Question 4. A. Show that if sigma is the surface of a solid G oriented by outward unit normal, then the volume of G is given by volume of G equal to 1 over 3 double integral sigma f dot n ds, where f xyz equal to xi plus yj plus zk and n is on outer unit normal to sigma. So f xyz equal to xi plus yj plus zk across the surface sigma of the solid J is given by phi equal to double integral sigma f dot n ds equal to triple integral G divergence f dv, where we have used the divergence theorem. Since divergence is equal to 3, the result is phi equal to double integral sigma f dot n ds equal to triple integral G 3 dv equal to 3 triple integral G dv equal to 3 volume of G. And we have shown that volume of G is equal to 1 over 3 double integral sigma f dot n ds. Question B. Use A to find the volume of the solid bounded by the paraboloid z equal to 1 plus x squared plus y squared and the plane z equal to 5. First, we need to sketch. So, this is the paraboloid z equal to 1 plus x squared plus y squared and the plane z equal to 5. This is the shadow of the paraboloid onto xy plane. We look from the top of the surface, so the end is pointing downward, negative n. The surface of the paraboloid is projected on xy plane. So we have double integral sigma f dot n ds equal to double integral sigma f dot negative gradient phi dA. dA is on xy plane. We have to find negative gradient phi. So phi is z minus x squared minus y squared minus 1. Then find the gradient phi first, and we get negative 2xi minus 2yj plus k. We want the negative gradient phi because the unit normal vector is downward. So negative gradient phi will be 2xi plus 2yj minus k. Next, f dot with the negative gradient phi, and we get 2x plus 2y minus 1. Region is on xy plane, and the region is circle. So dA is r dr d theta. From the circle, we know that the radius is from 0 to 2 and theta from 0 to 2 pi. For x should be r cos theta, and for y r sin theta. So we use from A to find the volume. 1 over 3 double integral sigma f dot n ds. Then we just substitute f dot negative gradient phi that we get before, and also substitute the limit of r 0 to 2 and theta 0 to 2 pi, and we get like this. After that, we integrate with dr. Then we get like this. And lastly, we integrate with d theta, and we get the volume is 32 over 9 minus 4 over 3 pi.
Okay, for question 5a, let n be the outer unit normal of the ellipsoidal surface sigma, where sigma x squared over 4 plus y squared over 9 plus z squared over 16 equal to 1, z greater than 0. And let f equal to yi plus x squared j plus in bracket x squared plus y squared half k. Use Stokes' theorem to evaluate the integral. So my sketch is like this. My drawing for ellipsoidal. So solution is when question said to evaluate the integral double integral delta cross f dot n ds. So we must use integral f dot dr. So for integral f1 dx and plus f2 dy plus f3 dz. So integration y dx plus x square dy plus x square plus y square to the power of half dz. So x, y, z we must change. We use x equal to r cos theta, y r sin theta, z equal to 0. So r for x is 2. So x is equal to 2 cos t, y equal to 3 sin t. So dx is equal to negative 2 sin t, dy equal to 3 cos t. So for dz is 0. So we integrate negative 6 sin square t plus 12 cos cube t dt. So limit for theta is from 0 to 2 pi. So we divide into 2, a and b. So for a, we integrate 0 to 2 pi negative 6 sine squared t dt. So when we integrate, we get negative 6 pi. For b is for integration 12 cos cube t dt. The limit is 0 to 2 pi, and then we get 0. So when we total up, a plus b, we get negative 6 pi.
Question B. Let f equal to 2xz I plus 3xyj minus z squared k. Use Gauss theorem to evaluate double integral sigma f dot n ds, where n is the outer unit normal to sigma and sigma is the surface of the solid in the first octane bounded by the plane y plus z equal to 4 and the elliptical cylinder x squared plus y squared equal to 16. Note that if they ask to evaluate double integral f dot n ds, which means we need to use triple integral divergent f dv. First, we need to sketch the elliptical cylinder x squared plus y squared equal to 16 and the plane y plus z equal to 4. The surface of the solid is on the first octave, so dv is dz r dr d theta because this is cylinder and we use cylindrical coordinates. Then we find the divergent f and we get the answer is 3x. Then we substitute the divergent f into the formula. Next, we substitute the limit. From this, we know that z from 0 to 4 minus y, r from 0 to 4, and theta from 0 to 1 over 2 pi. So x here should be r cos theta and y here should be r sin theta. So we get like this. To solve, first we integrate with dz and we get 3r squared cos theta multiplied with 4 minus r sin theta dr d theta. Then we integrate with dr and we get like this. And lastly, we integrate with d theta and we get the final answer is 64.